Python 3 Object-Oriented Programming. Classes. We have previously looked at two paradigms of programming: imperative, using statements, loops, and functions as subroutines, and functional, using pure functions, higher order functions, and recursion. Another very popular paradigm is object-oriented programming, otherwise known as OOP. Objects are created using classes, which are actually the focal point of OOP. The class describes what the object will be, but is separate from the object itself. In other words, a class can be described as an object's blueprint, description, or definition. You can use the same class as a blueprint for creating multiple different objects. Classes are created using the keyword class and an indented block which contains class methods, which are functions. Below is an example of a simple class and its objects. Class cat, colon, and we have def, double underscore init, double underscore, and in parentheses we have self, comma, color, comma, legs, colon. Self.color equals color, self.legs equals legs. So that's the whole class cat with one constructor, the initialization constructor. Outside of the class cat, we have three instances of cat. Felix, Rover, and Stumpy are three different instances of cat. Felix equals cat, parentheses, ginger, comma, 4. Rover equals cat, parentheses, dog colored, comma, 4. And Stumpy equals cat, parentheses, brown, comma, 3. So each of these cat objects instances have a color and how many legs they have. This code defines a class named cat, which has two attributes, color and legs. Then the class is used to create three separate objects of that class. What type of object is a method? It's a function. The double underscore init double underscore method is the most important method of a class. This is called when an instance or object of the class is created using the class name as a function. All methods must have self as their first parameter, although it isn't explicitly passed. Python adds the self argument to the list for you. You do not need to include it when you call the methods. You do not need to include it when you call the methods. Within a method definition, self refers to the instance calling the method. The instances of a class have attributes, which are pieces of data associated with them. In this example, cat instances have attributes, color, and legs. These can be accessed by putting a dot and the attribute name after the instance. In an underscore init underscore method, self.attribute can therefore be used to set the initial value of an instance's attributes. For example, class cat, def double underscore init double underscore, in parentheses you have three parameters: the self one, which is always first, the color one, and the legs one, three parameters, followed by two statements: self.color equals color and self.legs equals legs. After the method for the class cat, we're outside of the class, we're creating an instance of the cat class, Felix. Isn't one instance? Felix equals cat. In parentheses, we have the string ginger, which replaces color, and the number 4, which replaces legs. Then we use the print command to print, parentheses, Felix, which is the name of the object, the cat object, dot operator, and then we access color. So print Felix.color will give us the output of ginger. In the example above, the underscore init underscore method takes two arguments and assigns them to the object's attributes. The underscore init underscore method is called the class constructor. Fill in the blanks to create a class and its constructor, taking one argument and assigning it to the name attribute. Then create an object of the class. So we're creating a class first. So use the keyword class student, colon. Underneath and indented, we have def. Okay, so what's the name of the constructor? Double underscore init for initialization, double underscore, parentheses, we have self, comma, name, colon, and indented, again, we have self dot name equals name. Under that, and lined up with class, it's actually outside of the class, we have test equals student, parentheses, the string Bob. So close up your parenthesis, and that's it. Test is an instance of the student class. Classes can have other methods defined to add functionality to them. Remember that all methods must have self as their first parameter. These methods are accessed using the same dot syntax as attributes. For example, class dog. Class dog has two methods here, def underscore init underscore. That's our constructor, and it's got three parameters, self, name, and color. Underneath that and indented, we have self.name equals name and self.color equals color. After that, we have a bark method, def bark, parentheses, self. So bark has one parameter called self. And underneath that, we have print the string woof. Outside of the class dog, we create an instance of the class. And this instance is called Fido. So Fido equals dog. And then in parentheses, we answer name and color with Fido and brown. Then we use the print command. And in parentheses, we use the instance name, which is Fido, the dot operator. And then we use name to access the value of name, which gives us Fido if you look down at result. Then we use the instance again, Fido, with the dot operator again, to call the bark method. Fido.bark, empty parentheses, that's a method. And as you can see at the bottom, it says woof. Classes can also have class attributes created by assigning variables within the body of the class. These can be accessed either from instances of the class or the class itself. For example, we have class dog, underneath which legs is set equal to 4. Underneath that class attribute, we have the class constructor, def underscore init underscore, and in parentheses we have self, name, and color as parameters. Underneath the initialization method, we have self.name equals name and self.color equals color. Outside of the class dog, we create an instance of the class. This instance name is Fido. Fido equals dog, and in parentheses, Fido replaces name and brown replaces color. Then we use the print command to print. You use the instance again called Fido, the dot operator, and then the attribute, which is legs, which is going to give us an output of 4. And then you use the print command again, which in the parentheses you're going to call the class dot legs, which also gives us 4. So this is letting you know that you can call the attribute by either the name of the class or the instance name of the class. Class attributes are shared by all instances of the class. So legs equals 4 in bold. If you made 10 different instances of dog, Fido equals, Shadow equals, Stormy equals, Blackie equals, yada, 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 they all would be able to access Fido.legs or Stormy.legs or Shadow.legs or Dog.legs the way that it's set up. Fill in the blanks to create a class with a method say hi. So we start off with class student, follow student with a colon. We are going to create the constructor, the student constructor, like this. Def, double underscore init, double underscore, in parentheses, self and name. So we have two parameters, the first one always being self, underneath which we have self.name equals name. We want to create a method say hi, so we start off with the def keyword. Def say hi. And what do we put inside of the parentheses here? Def say hi self, because every method has to have, at least if nothing else, the self parameter. Okay, so def hi parentheses self colon, underneath which we have print, and in parentheses we have the string hi from plus, what is it, self.name. And then outside of that method, we have an instance of the student class called S1. So S1 equals student, and in parentheses we have the string Amy, which represents the student's name. Under that, we use the S1 with the dot operator to call the say hi method. Trying to access an attribute of an instance that isn't defined causes an attribute error. This also applies when you call an undefined method. So let's take a look at these problems. Here we have class rectangle, under which we have the rectangle constructor, def, double underscore, init, double underscore, and in the parentheses we have three parameters, self, width, and height, underneath which we have self.width equals width and self.height equals height. Outside of that initialization method, we have an instance of the rectangle called rect. Rect equals rectangle, and in parentheses, we have 7 and 8. 7 which replaces width, and 8 which replaces height. Under that, we use the print command, and in parentheses, we use the instance of the class called rect, the dot operator, and then we pull out color. Well, if we look at the class rectangle, we didn't create color. There's no color. We don't have self, width, height, and color. We have no color there at all. And we don't have self.color equals color. So when we try to reach out for something that is not there, you get the result attribute error. Rectangle object has no attribute color. What error is caused by trying to access unknown attributes? Attribute error. All right, inheritance. Inheritance provides a way to share functionality between classes. Imagine several classes, cat, dog, rabbit, and so on. Although they may differ in some ways, like only dog might have the method bark, they're likely to be similar in others, all having the attributes color and name. This similarity can be expressed by making them all inherit from a superclass called animal, which contains the shared functionality. To inherit a class from another class, put the superclass name in parentheses after the class name. So here we have class animal. This is the superclass. We have the constructor for animal, def, double underscore, init, double underscore, and we have three parameters, self, name, and color, followed by self.name equals name and self.color equals color. After which we have a cat class, class cat, and in parentheses we have animal, which means cat inherits from animal. We have a method for cat, def per, parentheses self, under which we have print the string per. We also create another class, class dog, which also inherits from animal, under which we have def bark, parentheses self, under which we have print woof. So we have three classes, one superclass and two subclasses. Then we create an instance of the dog class with Fido equals dog, and we give it two arguments. We give it the string Fido to represent name, and we give it the string brown to represent color, because dog inherits from animal, so the name and color parameters are usable here. Then we use the print command to print, and in parentheses we use the instance Fido with the dot operator to also call color, and then we use the instance of the class Fido with the dot operator to call the method bark. So as you can see, your output is brown on the first line and woof on the second. Which piece of code shows a new class spam inheriting from egg? We're inheriting from egg, so egg has to be in the parentheses. So class spam parentheses egg is what we want. A class that inherits from another class is called a subclass. A class that is inherited from is called a superclass. If a class inherits from another with the same attributes or methods, it overrides them. For instance, here we have class wolf. We have the constructor for wolf, def, double underscore, init, double underscore with three parameters, self, name, and color, followed by self.name equals name and self.color equals color. Wolf also has a method, def bark, parentheses self, under which has print the string gur. After the wolf class, we create the dog class. So we have class dog, and we want it to inherit from wolf, so we put wolf in parentheses after dog. Underneath which we have a method called def bark, parentheses self, exactly the same as the wolf def bark, parentheses self, but this one has print woof instead of print gur. So the wolf will growl and the dog will woof. After the dog class, we create an instance of the dog class called husky. Husky equals dog, And in parentheses, we use the string Max to represent name and the string Gray to represent color. Because dog inherits from wolf, name and color work for the dog class as well. We also use the husky with the dot operator to call the bark method. And which bark method do you think it's going to call? Well, because husky is created as a dog class, it is going to give us woof. And as you can see in the result, that's exactly what you see output, woof. In the example above, wolf is the superclass and dog is the subclass. What is the result of this code? Class A, def method self, will print 1. In class B that inherits from A, def method self will print 2. We are going to be out of both classes. We are going to use the B class, B parentheses dot method parentheses. So the B class method will print what? It should print 2 because it overrides, even though it inherits from A, because it has the exact same name of the method, it will override it. So it will print out 2. Inheritance can also be indirect. One class can inherit from another, and that class can inherit from a third class. So here we have 3 classes. We have class A, class B, and class C. A is the superclass, and it has def method self, which prints out the string A method. Then we have class B, which inherits from A, and its method is def another underscore method, parentheses self, which prints the string B method. Now notice class A's method is named method, class B's method is named another method. Finally, you have class C, which inherits from B, and it has a method called def third underscore method, parentheses self, which prints the string C method. So you have 3 classes. A is the only one that doesn't inherit from anything else. C inherits from B, B inherits from A. Here we're going to create an instance of the C class. So we have lowercase c equals uppercase c parentheses. Okay, so now pay attention to class C because that's the instance that we created, an instance of the C class. When we have the instance C with the dot operator calling method, the C class doesn't have its own method called method. The C class has its own method called third method. But C inherits from B, which also inherits from A, and in A is where you see the def method. So you will see the output A method first. And if you look down in the result, you see that. The second line of code is telling you to use the instance of the C class, C, the dot operator, and now it wants you to call another method. Well, again, C doesn't have its own method called another method, but it does inherit from B, and B does have a method called another method, which prints out the string B method. And as you can see, if you look at the result, the second line of code says B method. Lastly, we have the instance C with a dot operator calling third method. So where is third method? Third method actually resides in class C, which prints out the string C method. And so that's why you see the last line of code, the string C method. However, circular inheritance is not possible. So we can't say that C inherits from B, B inherits from A, and A inherits from C. We can't make this go in a circle. It's unidirectional. What is the result of this code? You have class A, and it's a superclass because it has nothing in parentheses after it. You have def A, self, print 1. You have class B, which inherits from A, that also has def A, self, but this one has print 2. So class B overrides class A because it's got the exact same name. The method is A in both class A and class B, but B overrides. Then you have a class B that inherits. You have a class C that inherits from B, and this class has a method called C. So def C parentheses self, which prints out a 3. We create an instance of the C class. So we have lowercase c equals uppercase C parentheses. So then we use that instance C with a dot operator to call the A method. Well, C first inherits from B, and B has an A method, which prints out 2. So our output should be 2 because that's the next direct inline inheritance, C to B. The function super is useful inheritance-related function that refers to the parent class. It can be used to find the method with a certain name in an object superclass. So that's kind of cool. You have class A with a method called spam. So it has def spam parentheses self, which prints a 1. Then you have class B, which inherits from A, that also has a method called spam, def spam self. B's method overrides A method, and that prints out a 2. So the first thing, if you were going to use the B class, the first thing it would do is print 2, and then by using super.spam, you're going to go to B's superclass, which is A's, and call its spam method, which prints a 1. So in the very bottom line, when we have B class represented by the empty parameter, B empty parentheses dot spam empty parentheses, we're looking at class B. We're calling its spam method because its spam method is spelled the same as A, but it overrides because it's spelling the same. So we're going to print a 2 first, and then super spam is going to call class A's spam method, which prints a 1. So when you see the result, the first line being a 2 and the second line being a 1, that's why. Super spam calls the spam method of the superclass. What is the superclass of a class? It is an instance of, or it is the class it inherits from. It's the class it inherits from. Magic methods and operator overloading. Magic methods are special methods which have double underscores at the beginning and end of their names. They are also known as dunders. So far, the only one we have encountered is the double underscore init double underscore, but there are several others. They are used to create functionality that can't be represented as a normal method. One common use of them is operator overloading. This means defining operators for custom classes that allow operators such as plus and times to be used on them. An example of a magic method is double underscore add double underscore for the plus symbol. So let's see how this works. We have class vector2d, which has 2 methods. It has the constructor, which is def double underscore init double underscore, and it's got 3 parameters: the self, which it has to have, and 2 additional, which are x and y. Underneath which this method has self.x equals x and self.y equals y. It has another method, def, and this is another magic method because it's going to overload the operator. Def double underscore add double underscore, it has 2 parameters. Again, it must have the self, and then it has an additional one called other. Now, this method uses the return keyword. It returns vector2d parentheses self.x plus other.x, comma, self.y plus other.y. Now, outside of that method, outside of the class actually, we are creating 2 instances of the vector2d class. The first instance is called first. So first equals vector2d, and in parentheses 5 replaces x and 7 replaces y. Then we have the second instance of vector2d called second. Second equals vector2d parentheses 3, which replaces x, and 9, which replaces y. Then on the right-hand side of the equals assignment, we have the value of first plus second, and we put that value into result. Then, when we use the print command, print parentheses result.x, you get 8 because the x is represented by first's vector2d 5, and in the second vector2d, the x is represented by 3. So 5 plus 3 is 8. Then when we have print parentheses result.y, we're going to add the first and second's values for the y's, which are 7 and 9. 7 and 9 is 16. So we took the plus sign and we gave it its own special operation instead of your normal addition, we kind of we programmed it to do what we wanted it to do. The double underscore add double underscore method allows for the definition of a custom behavior for the plus operator in our class. As you can see, it adds the corresponding attributes of the objects and returns the new object containing the result. Once it's defined, we can add two objects of the class together. What is the magic method for creating an instance? That would be the double underscore init double underscore. More magic methods for common operators. All right, so you have double underscore sub double underscore for minus, double underscore mul double underscore for multiplication, double underscore true div double underscore for division, double underscore floor div double underscore for floor division, mod for modulo, pow for power, and for the and symbol, XOR for that caret, and OR for the pipe symbol. The expression x plus y is translated into x dot double underscore add double underscore parentheses y. You're taking the double underscore add double underscore and placing it in between x dot and y in parentheses. All right, however, if x hasn't implemented the double underscore and double underscore, and x and y are of different types, then y dot double underscore rad double underscore and then x in parentheses is called. So you got to pay attention to that. It's kind of confusing. If x hasn't implemented the magic add and x and y are of different types, then instead of calling x dot the magic method with y in parentheses, you're going to call y dot the magic method with an r in front of it. That may be like reverse with x in the parentheses. So I don't know how else to describe it, but what I see. There are equivalent R methods for all magic methods just mentioned. So let's take a look at this example. We have class special string. The constructor is def double underscore init double underscore with two parameters, self and count, which underneath that is self.cont equals cont. Then you have the magic method, def underscore true div under double underscore, two parameters here, self and other. The two lines of code that are the body of this method are line equals, the string equals times len parenthesis other dot cont, and the next line is return the string backslash n, which gives you a new line, dot join. In parentheses you have a list as indicated in square brackets, and that is the value of self.cont, comma line, comma other.cont. Okay. After that method, you have two instances of the special string class. The first instance is called spam. Spam equals special string, and in parentheses you have the string spam. And then the second instance is hello, and it's hello equals special string, parentheses the string hello world. So then when we use the print command to print what's in the parentheses, spam with that / hello, that / is representing our magic true div. So we get spam. The division is going to give us this dashed line, and then it's going to return hello world. All right. In the example above, we defined the division operation for our class special string. What is, and I can never remember what that symbol means. I got to go back. I don't know what that symbol means. XOR. That caret symbol means XOR. What does Class A XOR Class B evaluated as if A doesn't implement any magic methods? I think we're going to use the reversal XOR. And because the order is A XOR B, we're going to use the reversal, which means we're going to start with the B, we're going to use the reverse XOR, and we're going to end with the A. So I'm going to guess it's this one here in the middle. And I'm good. Okay, magic methods. Python also provides magic methods for comparisons. So we have double underscore LT, double underscore for less than, double underscore LE, double underscore for less than or equal, double underscore EQ, double underscore for equality, which is the double equal sign, double underscore NE, double underscore for not equal to, double underscore GT, double underscore for greater than, double underscore GE, double underscore for greater than or equal to. If double underscore NE, double underscore is not implemented, it returns the opposite of double underscore EQ, double underscore. So the NE stands for not equal. If it's not implemented, it returns the opposite of the equal. There are no other relationships between the other operators. Here's the example they're showing. Class special string with the constructor def, double underscore, init, double underscore with two parameters, self and cont, under which we have self.cont equals cont. The next method is def. This is a magic method, def double underscore GT double underscore, which is the magic method greater than. So when we use the greater than symbol later in the code, this magic method is going to do something special other than what we assume the greater than symbol to do. We're specializing what the symbol does, and we're doing it like this. So the magic method for the greater than symbol has two parameters, self and other. We have a for loop here for index in range, parentheses len, parentheses other dot cont. Outside of that parentheses we have +1. Result equals other dot cont, and then you have in straight brackets colon index plus the string greater than symbol plus self dot cont. The next line is result plus equals the string greater than plus the value of other dot cont, straight brackets index with a colon after it. The last line of this method is print, and in parentheses the value of result. Alright, so the three lines of code after that magic method for greater than, we have spam. we have two instances of the special string class. The first instance is called spam, so spam equals special string, parentheses the string spam, which, what does spam replace? Cont, I guess. Contains, maybe? Maybe cont is short for contains. And then eggs is the second object of special string. So eggs equals special string, parentheses the string eggs. So now there, eggs is replacing cont, I guess, for contains. So when we have spam with a greater than symbol eggs, the greater than symbol is calling that magic method. And I'm just going to read the result and practice this sometime on my own instead of trying to explain it. Our first line outputs the greater than symbol spam, the greater than symbol eggs. The next line is the greater than is the E with the greater than symbol spam, the greater than symbol GGS. Next line is EG, greater than symbol spam, greater than symbol GS. Next, EGG, greater than symbol spam, greater than symbol S. And lastly, eggs, greater than symbol spam, greater than symbol. That's the strange result you get based on that code that specializes what the greater than symbol does by giving it a magic method to represent. As you can see, you can define any custom behavior for the overloaded operators. What is double underscore LE double underscore a magic method for? That's less than or equal. So here we show x less than or equal to y. So that's what it represents. Okay, then we have, there's several magic methods for making classes act like containers. So, how do we make classes act like containers? Double underscore len, double underscore for length, double underscore get item, double underscore for indexing, double underscore set item, double underscore for assigning to indexed values, double underscore del item, double underscore for deleting indexed values, double underscore iter, like for short for iteration, double underscore for iteration over objects, for example, in for loops, double underscore contains double underscore for in, and there are many other magic methods we won't cover here, such as double underscore call, double underscore for calling objects as functions, double underscore int, double underscore str, short for string, double underscore, and the like, for converting objects to built-in types. So let's look at the example here. We have import random. Then we have a class called vagueList, under which we have the constructor def, double underscore init, double underscore. It has two parameters, self and cont, which under that is self.cont equals cont. Again, I think cont is short for contains. Then we have another method, def. We have two magic methods after that. First, def underscore, double underscore get item, double underscore with two parameters, self and index, under which the body of that method is return self.cont, and then in square brackets we have index plus random.randint parentheses -1, comma 1. The next magic method is def double underscore len double underscore parentheses self, under which we have a single line of code for the body of that, and that's return random.randint parentheses 0, comma len parentheses self.cont times 2. Okay, so there's the class vagueList with its three methods. Outside of the class vagueList, we create an object of the class, which is called vague underscore list. VagueList equals the name of the class vagueList, and in parentheses we actually have a list, and a list is nested inside of straight brackets, and the list items in the list are all capital letters, A, B, C, D, and E. So vagueList represents that list. Then we use the print, followed by parentheses with len, which normally is for length, but we gave it a magic method for length. Instead of giving it what we normally use length for, we did return random.randint parentheses 0, comma the length of the self.cont times 2. And then we have print again, the exact same code. We give print len vagueList again, because we're dealing with the random and randint methods. Each time you run this, you should get the first two numbers different. The result here is showing a 6 and a 7, but if you keep running it, you should get different numbers. The last two print commands are print parentheses vague underscore list index 2, and print vague underscore list index 2 again. Alrighty. And in this case, it's going to print out two random letters from the list. Alright, so let's get out of this one. We have overridden the len function, which is short for length, for the class vagueList to return a random number. The indexing function also returns a random item in a range from the list based on the expression. Which magic method call is made by x index y equals z? I think this is the set item. And so I'm going to go with this middle one. X dot underscore set item underscore parentheses y comma z. And that's right. Object life cycle. The life cycle of an object is made up of its creation, manipulation, and destruction. The first stage of the life cycle of an object is the definition of the class to which it belongs. The next stage is the instantiation of an object when the double underscore in a double underscore is called, otherwise better known as the constructor. Memory is allocated to store the instance, and just before this occurs, the double underscore new double underscore method of the class is called. This is usually overridden only in special cases. After this has happened, the object is ready to be used. Other code can then interact with the object by calling functions on it and accessing its attributes. Eventually, it will finish being used and can be destroyed. Which stage corresponds to the double underscore init double underscore method being called? That would be the instantiation. When an object is destroyed, the memory allocated to it is freed up and can be used for other purposes. Destruction of an object occurs when its reference count reaches 0. Reference count is the number of variables and other elements that refer to an object. If nothing is referred to it, it has a reference count of 0. Nothing can interact with it, so it can be safely deleted. In some situations, 2 or more objects can be referred to by each other only, and therefore can be deleted as well. The DEL statement reduces the reference count of an object by 1, and this often leads to its deletion. The magic method for the DEL statement is the double underscore DEL double underscore. The process of deleting objects when they are no longer needed is called garbage collection. In summary, an object's reference count increases when it is assigned a new name or placed in a container like a list, tuple, or dictionary. The object's reference count decreases when it's deleted with DEL, its reference is reassigned, or its reference goes out of scope. When an object's reference count reaches 0, Python automatically deletes it. Our example here is A equals 42, which creates an object. Then B equals A increases the reference count of 42. Then when we take C is equal to a list A, that increases the reference count of 42. Next, when we use the DEL A, that decreases the reference count of 42. When we take B and reassign it from A to 100, that will also decrease the reference count of 42. When we take C with the index of 0 and we set that to -1, that will also decrease the reference count of 42. Lower level languages like C don't have this kind of automatic memory management. What is double underscore DEL double underscore the magic method for? Delete instance, DEL instance. All right, let's look at data hiding. A key part of object-oriented programming is encapsulation, which involves packaging of related variables and functions into a single, easy-to-use object, an instance of the class. A related concept is data hiding, which states that implementation details of a class should be hidden and a clean standard interface be presented for those who want to use the class. In other programming languages, this is usually done with private methods and attributes, which block external access to certain methods and attributes in a class. In Python philosophy, it's slightly different. It's often stated that we are all consenting adults here, meaning that you shouldn't put arbitrary restrictions on accessing parts of a class. Hence, there are no ways of enforcing a method or attribute to be strictly private. However, there are ways to discourage people from accessing parts of a class, such as by denoting that it is an implementation detail and should be used at their own risk. What is a private method in Python? It is a method external code is discouraged from using. Weakly private methods and attributes have a single underscore at the beginning. This signals that they are private and shouldn't be used by external code. However, it's mostly only a convention and does not stop external code from accessing them. Its only actual effect is that from module underscore name import asterisk won't import variables that start with a single underscore. For example, here we have class K, and we have 3 methods for this class. The first one is the constructor, so def double underscore init double underscore with 2 parameters, self and contents, under which we have self dot underscore hidden list equals list parentheses contents. The next method we have is def push with 2 parameters, self and value, under which we have self dot underscore hidden list dot insert parentheses 0 comma value. The next method we have is def pop parentheses self, under which we have return self dot underscore hidden list dot pop parentheses -1. Lastly, we have def double underscore rep repr double underscore parentheses self, under which we have return the string k, and in parentheses we have a placeholder which is a empty curly brace dot format parentheses self dot underscore hidden list. Okay, so now we're done with class K. Now we're going to do some code dealing with it. We create an instance of the K class. The instance is in lowercase, so we have K spelled in lowercase equal to uppercase K, which is the name of the class, and in parentheses we actually have a list, as indicated by square brackets with 1, 2, and 3 inside and separated by commas. Well, we use print parentheses K to outprint that initial result, which gives us the word K, followed by parentheses, followed by a list enclosed in straight brackets 1, 2, 3. Then we use k.push parentheses 0, and after we do that command, we print out the value of K again, which this time, because we're pushing a 0 into the list, we get the word K followed by a parentheses followed by the list, which is a square brackets, and the list items this time are 0, 1, 2, 3, separated by commas. At that point, after we've pushed a 0 into the list, we use k.pop, and then we print the value of K again. Well, after we call the pop method, we get the output of the word K, the parentheses, and this time the list is 0, 1, 2. So push adds something to the beginning of the list. Pop takes something off of the end of the list. Then, finally, we have print, and this is just to prove to you that a single underscore in front of a variable makes it suggested not to be accessed out of the class, but you cannot force somebody from using it anyway. So this is showing you how you can forcefully use it anyway, basically at your own risk. So we have print parentheses K dot underscore hidden list, and you have a result here. It doesn't give you an error message, it lets you do it. You don't have the word K, you just have the list itself, which is the same list as previously. In square brackets you have 0, 1, 2. So in the code above, the attribute single underscore hidden list is marked as private, but it still can be accessed in the outside code. The double underscore repr double underscore magic method is used for string representation of the instance. What is the purpose of prefacing a method name with a single underscore? It's to mark it as private. Strongly private methods and attributes have double underscore at the beginning of their names. This causes their name to be mangled, which means that they can't be accessed from outside the class. The purpose of this isn't to ensure that they're kept private, but to avoid bugs if there are subclasses that have methods or attributes with the same names. Name-mangled methods can still be accessed externally, but by a different name. The method double underscore private method of class spam could be accessed externally like this. Single underscore, then the name of the class, which is spam, followed by the strongly private method double underscore private method. So here we have class spam. We have a strongly private attribute. It's not a method, it's an attribute, so it's double underscore egg equals 7. After which we have a method def print underscore egg parentheses self, under which we have the body print parentheses self dot double underscore egg. Outside of that method and outside of the class, we create an instance of the spam class with a lowercase s. So lowercase s equals spam. And then you have empty parentheses, because all we're doing is creating an object reference variable called s. Then you use that object reference variable s with a dot operator to try to access print underscore egg method. Then after that, actually that prints out a 7, the result of that. Then we have a print command, and in parentheses we use that s again with a dot operator, and the special way to call the double secure, double private underscore egg. So we have s dot single underscore spam, which is the class, double underscore egg, which is the private attribute. That gives us a 7 as well. But when we use the print command to try to use the object instance s with the dot operator and directly call the double underscore egg, which is a private, attribute, we get attribute error. Spam object has no attribute double underscore egg. So if you have a strongly private attribute or method, you have to preface that with the name of the class prefaced by a single underscore. Basically, Python protects those members by internally changing the name to include the class name as well. How would the attribute double underscore a of the class B be accessed from outside the class? Well, the class is B, so we go with the underscore B for starters to indicate the class, and then the double underscore a to indicate the private, attribute. I messed up. Can't back out. So underscore B double underscore a would be how you do that. Class and static methods. Methods of objects we've looked at so far are called by an instance of the class, which is then passed to the self parameter of the method. Class methods are different. They are called by the class, which is passed to the CLS parameter of the method. CLS short for class. A common use of these are factory methods, which instantiate an instance of the class using different parameters than those usually passed to the class constructor. Class methods are marked with a class method decorator. Again, a common use of the class methods are factory methods, which instantiate an instance of the class using different parameters than those usually passed to the class constructor, and the class methods are marked with a class method decorator. So we have a class rectangle here. It has 2 methods, and it has a class method. The first method is the constructor, so it's def double underscore init double underscore with 3 parameters, self, width, and height, followed by self.width equals width and self.height equals height. The next method is def calculate underscore area with 1 parameter of self, followed by return self.width times self.height. And then finally we have this class method, which starts off using this class method decorator, which is the @ symbol with the word class method. So @class method, now we have the class method underneath that decorator, def new underscore square, and here is where we have the parentheses where we use the CLS for class, and then the other parameter is side underscore length, which is followed by return CLS, and in parentheses we have side underscore length, comma side underscore length. So now we're done with the class rectangle and its three methods. And we want to create an instance of the rectangle class. This instance is called square. So in lowercase letters, we have square equals the name of the class, which is rectangle, capitalized, the dot operator, and then the class method, which is called new underscore square. We want to represent the length of the side. We want to replace side length with, in this case, 5. And after that, we use the print command, and in parentheses, we have square dot calculate underscore area, and an empty parentheses to indicate that that's a method. When we created an instance of square and set it and assigned to it rectangle.new square parentheses 5, we followed the instructions for that class method, and 5 became an output of 25 because 5 squared is 25, and the instructions that I just read actually calculate that based on the syntax that I read. New underscore square is a class method and is called on the class rather than on an instance of the class. It returns a new object of the class CLS. Technically, the parameters self and CLS are just conventions. They could be changed to anything else. However, they are universally followed, so it's wise to stick to using them. Fill in the blanks to make say hi a class method. We start off with class person, followed by the person constructor, which is def double underscore init double underscore in parentheses. We have two parameters, self and name, followed by self.name equals name. We want to make this a class method, so we need to use the decorator. So we have the @ symbol with the word class method all together, class method. Underneath that, we use the def keyword to define a method. So def say hi, and in parentheses we have CLS, followed by print the string hi. Static methods are similar to class methods, except they don't receive any additional arguments. They are identical to normal functions that belong to the class. They are marked with the static method decorator. For example, we have class pizza. We have the constructor for the class pizza, which is def double underscore init double underscore with two parameters, self and toppings, followed by self.toppings equals toppings. Now we have a static method with that decorator, the @ symbol, and the word static method, followed by def validate underscore topping with the parameter of topping, followed by an if-else condition. If topping double equals the string pineapple, then raise value error, in parentheses the string no pineapples, else, return true. After that static method, validate topping, we create a list. The name of the list is ingredients. Ingredients equals square brackets, 3 strings, cheese, onions, and Spam, separated by commas. Then we have an if condition that asks if all, parentheses, pizza.validate underscore topping, parentheses I, for I in ingredients, pizza, and this pizza is lowercase because it's an instance of the class pizza, lowercase pizza equals uppercase pizza, parentheses ingredients. Static methods behave like plain functions, except for the fact that you can call them from an instance of the class. Which of these methods is most likely to be a static method? Well, we have CLS and self, and that was for CLS is for class methods, and self is for regular class methods as well. And inside, not specialized decorated class methods, but when you make a method inside of a class definition, you use the keyword self. And since the only one that's left that doesn't match the two I just referred to is def span parentheses x comma y. I'm going to call that the static method, and it's right. Oh, let's go to properties. Properties provide a way of customizing access to instance attributes. They are created by putting the property decorator above a method, which means that when the instance attribute with the same name as the method is accessed, the method will be called instead. Okay, one common use of a property is to make an attribute read-only. So you're actually taking some control over the attribute, what the user can do with it. So here we have class pizza with the constructor def double underscore init double underscore, and in the parentheses we have two parameters, self and toppings, followed by self.toppings equals toppings. Here we create a property with the property decorator, the @ symbol of the word property, underneath which we have def pineapple underscore allowed parentheses self, underneath which we have return false. That's making pineapple allowed read-only. Underneath that, we are now out of the class. We will create an instance of the class pizza. So we have lowercase pizza equals uppercase pizza, and in parentheses we have a list that replaces toppings. The list is cheese, comma, tomato. And that list, like I said, that's the toppings here. We use the print command to print parentheses the instance of the class, which is lowercase pizza, the dot operator, and then the property pineapple underscore allowed. That gives us an output of false because we created pineapple allowed to be a property that returns false. We made it read-only. Now, after that, we took the pizza dot operator and pineapple underscore allowed, and we tried to change it by setting it equal, assigning it to true. And what happens is we got an attribute error, can't set attribute. We created it as read-only, so you cannot set that. You cannot make that change. It's read-only, period. Okay. Fill in the blanks to create an is adult property. So here we have a class called person. We have the constructor def double underscore init double underscore with two parameters, self and age, followed by self.age equals int parentheses age. So we are not just saying self.age equals age, we're actually making sure that it is converted into an integer data type. We want to create an is adult property, so we need the property decoration, which is the @ symbol and the word property. Underneath that, we have def is adult parentheses self colon, and we are going to put a constraint on this property is adult, and the constraint is an if-else statement. If self.age is greater than 18, and we want to follow that with a colon, then return true, else colon return false. So there's the constraint for the is adult property. Properties can also be set by defining setter and getter functions. The setter function sets the corresponding property's value. The getter gets the value. So to find a setter, you need to use a decorator of the same name as the property, followed by a dot and the setter keyword. And the same thing applies to defining getter functions. So let's look at the class pizza again. Here we have the class pizza with the constructor, which again is def double underscore init double underscore with two parameters in the parentheses, self and toppings, followed by self.toppings equals toppings and self.underscore pineapple underscore allowed equals false. Then we have a property as designated by the @ symbol and the word property, underneath which we have def pineapple underscore allowed parentheses self colon, followed by return self dot underscore pineapple underscore allowed. After that we have a setter, And so we have at pineapple underscore allowed dot setter, underneath which we have def pineapple underscore allowed, and in parentheses we have two parameters, self and value, followed by an if condition. If value, colon, followed by password equals input, parentheses, the string enter the password. What that does is it puts a line out that says enter the password. This is an input for the user to read. The user types a password in, and whatever the value of what they typed in, it goes into this variable called password. Then after they do that, we have another if condition. If password is equal to, and we use double equal symbol for equality, if password double equals, and then in double quotes you put whatever the password is that you're looking for, colon, self dot underscore pineapple underscore allowed equals value. So if they come up with the correct password, then we can set the value of the pineapple allowed. Only then, if their password is correct, can they change the read-only ability of pineapple allowed. So if they don't come up with the right password, it goes to the else condition, which will raise value error, and in parentheses we have the string alert intruder. Okay, so after that class, which has the constructor, a property, and a setter, after that whole class is done, we create an instance of the pizza class, again, with lowercase pizza being the instance, assigned to, with the single equals, the capitalized pizza, which is the class, and in parentheses, we have the toppings, which are a list enclosed in straight brackets of cheese and tomato strings separated by comma. After we create that list, we use the print command, and in parentheses, we use the instance pizza, which is lowercase pizza, a dot operator, and then the property pineapple underscore allowed. The first thing that happens is we get a false statement because pineapple allowed is originally created to be read-only, okay? The next thing that happens is we take pizza dot pineapple underscore allowed equals true. But before we set it to true, we get that enter a password. After the false statement results, then we get enter the password, and you try to enter the password, and if it's true, then it'll let you to change the value with the code pizza.pineapple allowed equals true. At which point we print in parentheses pizza.pineapple underscore allowed, the value of pizza pineapple allowed again. If you type in the correct password, it will let you change it to true. If you don't type, it won't let you change it. The code will change it to true. If you don't type in the correct password, you will get false again. Okay. Define a decorator that would be used to add a setter to the property egg. We're going to create a setter, so we have to use the decorator, the @ symbol, the name of the property, which is egg, so @egg dot setter. Okay, now let's look at a simple game. Wait, is that right? Let me see. Yeah, a simple game. Oh, now I have to go through this all again. Okay. We want to create an is-adult property. So we have to use that property. Def is adult self if self.age is greater than 18, colon, return true, else, colon, return false. Next. Okay. Define a decorator that would be used to add a setter to the property egg. @ symbol, egg and dot setter. Okay. All right, so now let's go to the simple game, which may not be so simple for you or me. Object orientation is very useful when managing different objects and their relations. That is especially useful when you're developing games with different characters and features. Let's look at an example project that shows how classes are used in game development. The game to be developed is an old-fashioned text-based adventure game. Below is the function handling input and simple parsing. So let's look at this function. Def get underscore input, empty parentheses, colon, followed by command equals input, parentheses, the string, a colon and a space, dot split. After which we have verb underscore word equals command index 0. Then we have if verb underscore word in verb underscore dict, followed by verb equals verb underscore dict, in square brackets, verb underscore word. Else, colon, followed by print, and in parentheses we have the string unknown verb with a placeholder there. Out of the double quotes we have dot format, and in parentheses verb underscore word. So whatever the value of verb underscore word is, it's going to go into that little curly brace placeholder there. Next we have an if-else condition. If len, parentheses, command is greater than or equal to 2, colon, noun underscore word equals command index 1. Print, parentheses, verb, parentheses, noun underscore word. Else, you will print, parentheses, verb, parentheses, the string nothing. Outside of that if-else, we have another function here, another method function, whatever. Def, say with one parameter, noun, colon, followed by return the string you said, and then we have another placeholder here enclosed in double quotes. Outside of all those quotes, we have a dot format, and in parentheses, we have the value of noun. Whatever the value of noun is going to go into this placeholder. All right, after that, we have a dictionary called verb underscore dict. So that's going to be like a verb dictionary, equals, and in the curly braces, which represent a dictionary, we have the key value pair. The key is the string say, followed by a colon, followed by the value say, and followed by a comma. After that, we use the while true colon to call get underscore input. This is the result. You get a colon in which you can type say hello, and if you type say, that is the key to the key value pair in verb. As long as you type the word say first with whatever you type, it will say you said whatever you typed. So if you type say blue, the answer will be you said blue. And if you type say tricycle, you will get the output you said tricycle. Now, if you don't use the word say, which is the only key in the verb dict dictionary, for instance, you type in test, you will get the result unknown verb test. You will not get you said test. You will get a totally different response. The code above takes input from the user and tries to match the first word with a command in verb dict. If a match is found, the corresponding function is called. What does the split method called on the input do? It divides the input into separate words. The next step is to use classes to represent game objects. So let's look at this from top to bottom again. We have class game object, and it's got 3 attributes before it gets into the methods. You have class underscore name equals an empty string. You've got desk, short for description, equal to an empty string. And then you've got objects set to an empty dictionary because it's in the curly braces. Objects set to an empty dictionary. All right, so Now let's look at the methods. We have two methods. We have our constructor, which uses that double underscore init double underscore, and we have get description, which is shortened by get underscore desk. Let's look at the first one. Def double underscore init double underscore parentheses two parameters, self and name, followed by self.name equals name, and then followed by game object, you call them the name of the class, dot objects, and in straight brackets you have self dot class underscore name equals self. So that's kind of a mouthful. After that constructor, we have another method, def get underscore desk with one parameter self. So this is the method to get the description. And that's followed by return self dot class underscore name plus the string of \n, which moves to the next line, plus the value of self.description, self.desk, D-E-S-C. Okay, so that finishes the game object class. Now we have another class. We have class Goblin, and it inherits from game object. So it gets all the goodies the game object has. We have, we get to set, in this class, because it inherits from game object, we get to set what class name's value is. Instead of class name having a value of an empty string, here class underscore name is going to be equal to the string goblin. And then instead of DESC, short for description, being set to an empty string, here we're going to give it a description. So DESC equals the string of foul creature. So the name is goblin and the description is a foul creature. Next, we are going to create an instance of the goblin class. So goblin in lowercase is the instance. It's assigned with a single equals symbol to the class name goblin, which is capitalized, and in parentheses and double quotes we have the string gobbly, which represents the name. After which we have a method that belongs to this class goblin, def examine with one parameter, which is noun, followed by an if-else condition. If noun in gameObject.objects, colon, return gameObject.objects, straight brackets noun dot get underscore desk. So that means get the description. Else, colon, return the string. There is no, and you've got a placeholder there as indicated by the empty curly brackets. Here, outside of the string double quotes, you have dot format with parentheses noun. So whatever the value of noun is going to go into that curly brace placeholder. Okay, so we created a goblin class which inherits from the game objects class. We also created a new function, examine, def examine parentheses noun, which returns the object's description. Now we can add a new examine verb to our dictionary and try it out. So now we take our verb dictionary named verb underscore dict, and we set it equal to, in our curly braces, 2 key value pairs. The first key value is the string say, a colon, with the value say, comma. The second string key value pair is the key is the string examine, a colon, and the value is examine, followed by a comma, and followed by the closing curly brace. So now combine this code with the one in our previous example and run the program. So here, when you run the program, you get your initial colon, and as long as you type in one of the keys, be it one of the keys is say, and the other key is examine, you'll get a certain type of output. So if you type in say hello, your response will be you said hello. If you type in examine goblin, you will get goblin followed by another line that gives you the description, which is a foul creature. So we go back up here. Here you see goblin and a foul creature. And there is examine goblin, goblin, a foul creature. Now, if you were to use examine elf, examine is the correct key in the verb dictionary, but elf is not a game object. We only have one game object, and that's a goblin, right? We didn't create another object instance. Another class instance. Goblin equals goblin gobbly. If you wanted to create an elf, you would have to say elf equals goblin elfie or whatever. Okay, but because there is no elf, we get the response, there is no elf here. Why does goblin inherit from game object? Because goblin is a kind of game object. A simple game. This code adds more detail to the goblin class and allows you to fight goblins. So from top to bottom, let's take a little peek. Class goblin, which inherits from game object, which is in the parentheses. We have our constructor for this, def double underscore init double underscore with two parameters, self and name, followed by self.class underscore name equals the string goblin, self.health equals 3, self.underscore desk equals the string of foul creature, and then super parentheses dot double underscore init double underscore parentheses name. Getting a little more complicated. Next we have a property that has an if, else, if conditionals. So you have the at property description. We have def, desk short for description, parameter is self, followed by if self.health is greater than or equal to 3, return self.underscore desk. Elif, which is like else if, but in Python it's elif, self.health is equal to 2, health underscore line equals the string, it has a wound on its knee. Elif self.health equals 1, health underscore line equals the string, its left arm has been cut off. Elif self.health is less than or equal to 0, health underscore line equals the string, it is dead. Lastly, we have return self.underscore desk plus the string of \n to go down a line, and then plus the value of health underscore line. So that's the property. Now let's create a setter. So at desk.setter, def desk with two parameters, self and value, followed by self.underscore desk equals value. Now we have another method, def hit with one parameter of noun, followed by some if conditions. If noun in GameObject.objects, thing equals GameObject.objects, straight brackets noun. The next if that's flowing, if type parentheses thing is equal to goblin, thing.health equals thing.health minus 1. The next if condition is if thing.health is less than or equal to 0, MSG short for message equals the string you killed the goblin. Else, MSG equals you hit the, and there's a placeholder indicated by the empty curly braces. Outside of the double quotes, we have the dot format, and then in parentheses, we have thing.class underscore name. So whatever the value of thing.class underscore name is, it's going to go into the value of that placeholder. The value is going to go into that placeholder there. You hit the blank. Else, and this is an outer else, MSG equals the string. There is no, and then there's placeholder here. Dot format, parentheses now. Noun. Whatever the value of noun is will go into that placeholder. There is no blank here. Lastly, we have return MSG. So here's an example of the result. You have the colon in which you can, let's see, hit goblin, getting, you hit the goblin in response, examine goblin, you get goblin, next line a foul creature, next line it has a wound on its knee, response, hit goblin again, will give you hit the goblin response. Hit goblin again, you have another response. You kill the goblin. Examine the goblin, you get a goblin. You get a space, you get goblin, a foul creature, it is dead. This was just a simple sample. You could create different classes, for example, elves, orcs, and humans, fight them, make them fight each other, and so on. Why was desk turned into a property? So it could be dynamically created when accessed. Module 7 quiz. How is a property created? It's using the property decorator. What is the difference between a class method and a static method? Class methods are past the calling class. Class methods are past the calling class. Static methods aren't. What are the usual parameter names for the calling instance and the calling class? The calling instance would be that, let's see, you have the self and CLS for class. What method is called just before an object is instantiated? It's the double underscore init double underscore. Fill in the blanks to make the egg attribute strongly private and access it from outside the class. So we have class test. Strongly means it's got double underscore, so double underscore egg equals 7. That's the attribute strongly. Then we create an instance of the test class, t equals test, empty parentheses. So now we have an instance of the class. We have the print command using the instance of the class t with the dot operator. We want to access the egg, but we have to call the class first with an underscore. So t dot underscore test double underscore egg. It's the only way you're going to get to that. All right. What is the automatic process by which unnecessary objects are deleted to free memory? That's garbage collection. Fill in the blanks to make a setter for the property name. Okay, it starts off class person with the constructor def underscore init underscore with two parameters, self and name, followed by self dot underscore name equals name. We have a property here with the at property decorator, under which we have def name with the parameter self, followed by return self dot underscore name. We want to make a setter, a setter for the property name. So we have the at symbol, the property name, which is name. So at name dot setter is the decorator, under which we have def name with two parameters, self and value, followed by self dot name equals value. Oh, I messed up. What did I do wrong? Oh, underscore name. Self dot underscore name equals value. Alrighty. Okay, and that finishes the object-oriented programming lesson.